And now we're going to be pretty much learning how to use technology to construct a histogram or distribution, aka corresponding polygon that goes with histogram. Using data that happens to be given data, so it's not in distribution form. So sometimes I have a very big list of data, and trying to find everything by hand will be very difficult. So, and it causes errors. But always be errors depending on how careful you are. So, come over here. We're going to definitely do that. So, for small data, how we can obtain the distribution. Just and just look at the exact same time to hit 2 birds with 1 stone, and pretty much using data itself. So let's go to the next slide. Where do I put my book? There it is. And we're pretty much using the CASIO, as you can see. So first of all, usually what happens is in general, sometimes block coding won't provide you the class width or the lower limit. Sometimes they'll say, I want you to just give me 5 classes, give me 8 classes, based on the data you have. And there's probably the 2 step process doing that. I'm not going to do that. Definitely could read up on it and figure out how it goes. But it's always running to the more convenient one. So what I ended up doing is I made a problem in which I chose a convenient lower limit to start at, and a convenient class width to use to ensure that the lower limit is in the first interval, and so the lower limit contains the minimum and it's in the first interval, while the maximum value is in the last interval. That's the whole objective, that's the whole goal. So sometimes you're modifying, making more convenient ones to make sure it is done for the certain amount of intervals that the problem wants. Over here, I don't care about how many intervals I want. I just want this to happen, and however intervals is being made, is being made. So, first thing first, is this very okay? If I look at this data and I want to make sure it's right, it's working good, I have to make sure that the convenient one for the lower limit is convenient for the minimum that's here. So I could find the medium not that difficult with this set of data, but it would be more difficult for big data. So we definitely see that it's 11. And our max happens to be over here, 84. So what I could be doing here is I can now be constructing the histogram or the table that goes with it. And what we're seeing here is if you do it through technology, you get it pretty quicker than what we're doing to build here. But I'm showing you how I would build it by hand, manually, and to pretty much get it done. So come over here, what we're seeing is, well, the first lower limit should be, I should do this in green, should be 10. I'm trying to figure, okay, what's going to be the next limit, lower limit? And these are rulings, okay? So over here, how do we get to the next lower limit? Well, what we do here is we add 15, which is the class interval, or in this case, the class width, or interval size. In our case, this here should become 25, and we see that. And we can continue the process again by simply adding 15 one more time. And if we were to add these guys together, it should end up becoming 40. And we'll pretty much continue the process. Well, again, doing my hand might take some time to these big numbers because decimals, it might be a little tricky, a little bit of work. But how can you get this done at a convenient pace? So we just understand how the calculator is working for the most part. That's the objective every single time. Know how technology works, so you can know its pitfalls and its advantages. So I'm going to turn mine on. And when we're doing any type of calculations or calculators, just use the run matrix, which is the calculator portion. Enter it, or go ahead and press 1. If you need it clear everything, it has a little delete right here. You can either delete a line or all. I'm just going to delete all. And it's pretty much F1 for yes. So everything's gone. I'm going to start clean slate. So come over here, what can we do? Well, the first thing is 10. And we said the first we're going to add 15 to get to the next real limit, which is 25. And it shows the same thing here. So I could add 15 again. notice how it says answer, shows answer right here. It says, oh, since you're not putting a number in front, I'm going to get the previous answer and add 15. I'm going to do what you're asking to do to the operation. And it does it. But we don't have to do that if it's going to be the same value over again. We don't have to do that. All I got to do is just keep pressing enter and notice how it just continues adding if you want. And I'll do one more click for these right there. And there we go. So that's the thing about it. So calculator can see patterns. Almost every technology now can see patterns in terms of the operations that you do. So if it's the same operation over and over again, you can just continue pressing enter and it will have fun. So over here, we're ending up with 55, followed by 70, and then we have over 85. So this is where we notice something interesting. And understand that these are the real limits, okay? These are the real limits. So I'll put over here R, L, and once again, whenever I write R, L, I'm referring to real limits. So I'll write here real limit. Put it closer. Real limit. It's the same thing as saying R, L. So that's out the way. And if I say boundary point, that's going to be BP. So therefore I can write things a lot quicker. So RL, and then what we're saying here is from lower to lower limit, those are the real limits. So we're looking over here, we're looking at 10 to 25, 25 to 40, 40 to 55, 55 to 70, 70 to 85. And for the limits in here, for the real limit, notice how the max that I'm looking at is between these guys, these the real limits. So that means that we don't have to go any further than this. We can stop here. So now let's go ahead and construct the upper limits. So upper limits is just one less than these guys. For whole numbers, one, because they'll go based off one. If it's decimals, go based off corresponding to decimals. So if it's based off one decimal place, it's 0.1. If it's two decimal places, it's 0.01. And that's usually what happens. It's the same typical pattern. What's happening based off the 30 units you're basing it off of, or the basis you're basing it off of. Anyways, come over here. Therefore, we're saying that this one here should be 8984 because one less than this guy. Shift over here. Instead of ending it at 70, it's going to be one less than it, so it should be 69. Imagine repeat the whole process again. 54, 39, 24. So typically that's how you find your real limits. But sometimes your book might want to do boundary points instead. So how do the boundary point works? Because once again, it depends on your book, depends on your teacher, and which they prefer. So come over here. On the boundary point for B, boundary points. And therefore, I know that if I go halfway between 24 and 25, it's going to become 24.5. So the boundary point is just halfway between the upper and lower limit of the two intervals. That's what we're seeing. So over here, same thing, if I go halfway between 39 and 40, it's going to become 39.5. Hopefully, we start to see a pattern within it, and we clearly see that either I'm going to increase by 0.5 the upper limit, or I'm going to decrease 0.5 by the lower limit. And we're going to end up at the same distance anyway, because we're meeting ourselves halfway. So if I just increase by 0.5, I'm looking at 54.5. If I increase by 0.5, I'm looking at 69.5. If I increase this one by 0.5, I'm looking at 84.5. And that's making sense because it's halfway between. And I still need to put the boundary for this guy that corresponds to this 10. So therefore, I'll just go ahead and decrease it by 0.5. And that's equal to 9.5. Because once again, what's over here, it's a 9 actually. Then between 9 and 10 is 9.5. So that's pretty much how we can get our corresponding boundary points, right there. So once again, like I said before, it depends on what you're doing in the book. You can just rely on it. So now we pretty much can start graphing things and obtain frequency distribution. Because the CASIO didn't have to do it. Actually, you could CASIO to do all this stuff for you. It would actually have done this for you in CASIO. And we'll see that. Well, I mean, not everything, but on the histogram. On the histogram. Keep that in mind. I'm referring to the histogram. So come over here. I'm going to turn it back on. So how to get to the histogram and get things in? Well, what I'm going to do over here is I have to go to menu and I'm going to get statistics. So I'm going to hit statistics. Notice how over here in this too I have stuff in. So I'm going to show you a few things that will be helpful in the future where as you're doing things. And that's the idea of deleting, replacing, inserting, and replacing and all that good stuff. So over here, notice how we have this information, but then here it says anything about deleting. I want to get rid of this eventually, but I have nothing about deleting. It turns out we didn't make this form, but if you don't see this setup, just hit exit. Or something you might do is shift quit. Sometimes depending on the situation. But anyways, in this format, which I grab calculate test, if I press the right arrow, the button corresponds to it, I actually see edit, which allows me to edit a value. I see delete, which means delete a value. I see insert, which means to insert between values. And over here, we see delete all, which means I'm going to delete everything in that list. That's what delete all means. So let's say, I wasn't supposed to have 38 here. It was supposed to be 3, then 8. So what I could do, I say, let me just first put the 3. Or in this case, let me just first put the 8. Since it's a bigger number, I'll put 8, enter. But before that was supposed to be a 3. So in between 3 and 8 was supposed to be another 3. So what I could do here is, where 8 is, I'll press insert instead. And what it does, it gives me a space to put 3. So now I can do that, and I can say, no, let me just clearly put the 8 there, 3. And so it's going to be 0 should be 3, and it gets replaced. So that's how we could pretty much edit, so we can edit on it, and we can insert, if we need to insert, if we're missing something. If you need to delete this one, well, where did that come from? It was just supposed to be 50. It was just 55. It wasn't supposed to be there at all. So what I could do here is, I said I want to delete that one, I just press delete here, or I could delete here. But if I delete here, see what happens. It goes away. So I could delete either or, from here, or delete here. So, let's say, okay, I don't want this, this I don't want. What I could do here is, I'm going to do delete all, which is right there in black. So I could do delete all, and then ask the question, are you sure you want to delete this list? Yes, press 1. No, press F6. So I want to delete it, so I press F1, and it's gone. So we have kind of a clear slate here. So now we'll go here, I'm going to come over here to list 1, and nothing. So what we're going to do here is, all the values that we can see over here in the data set, we're going to put all this in this one. So just keep putting it on this one. All this guy could fit in this one. So you can either build it horizontally, or you can put it vertically. Truly your choice, as long as they're all there, or it doesn't matter here. As long as they're all there, we're good. When you get frequency distribution, order doesn't matter. We'll see that. Anyways, just go and start inputting. So go at your own pace. I'll do mine. So 32, 22, 11, 47, 20, 27, 40, 65, 18, 25, 35, 54, 21, 30, 43, 84, 20, 25, 38, 58. So sometimes I do make errors, even though I say the number, I do kind of switch the numbers around or press the wrong button, even though I'm saying it to myself. So it's always good to double check it because we don't want to have any type of data entry error. Okay? We'd rather have something error, not data entry error. Well, we'd rather not have any of it, to be honest. But let me just go ahead and come up here and just make sure everything's clear. Well, one thing we definitely know here is, hey, notice how on the left side you see sub, you see 20, and that's the last number. So for mine, it was 58. So I have all 20 data there. That's good because 5 across times 4 down is 20. So we know the number of observations we're seeing here is 20. That's good. So it's consistent. The question is, do I make any timing error in there? That becomes the important thing. So I don't need to insert anything. I don't need anything. The question is, do I need to replace or edit? So come over here. We're going to check at the very top. Well, 32 is good. 22 is good. 11 is good. 47 is good. 20 is good. 27 is good. 40 is good. 65 is good. 18 is good. 25 is good. 35 is good. 54 is good. 21 is good. 30 is good. 43 is good. 84 is good. 20 is good. 25 is good. 38 is good. And 58 is good. Okay, I'm sorry. I have nothing to worry about. So I don't have to worry about any type of data error entry because I double checked it, maybe sometimes triple check. So we're good there. So how do I get this job to work? Well, first thing first, what we're doing, we're just gonna, I want to exit this, so we could either press exit, we can't get to the graph version. Over here, press exit, notice I can't go back. So I'm gonna do shift, exit, quit. So I'm gonna quit it. So that's what I did there. But the reason why I couldn't go back is because in reality, I was in the same list. I should have just went right again, and it was there. But sometimes you won't notice it, won't notice it, just quit it, and then you start from scratch. Okay. So come over here. I want to go to graph. But first thing I want to make sure is that when I make selections, I want to make sure that I only want the first one on, or graph 1 on. So I'm going to pretty much put enter graph 1, and you see right here, we see on and off. So I'm going to press on. It's on now. But over here at graph 3, I want it off. So I'm going to press off. So it's off now. So those are good. Now, on means show me, off means don't show me. If you have off, if you have on, and you have lists that don't have any data, it's going to give you some type of error called a dimension error. And I can illustrate right now what I mean. So let's just say, let me turn this on and we'll see it. So turn it back on. We say, wait, no data. So therefore, we have to exit. It's going to say first thing we gave it to do so. But right here, I'm going to set. And I'm going to set graph 1 to have the histogram. So if that's not there, have it highlighted. And right here are your options. So notice the histogram is not here in the first option. So we're going to do the forward to the right, press the button that corresponds to it, and guess what? It's right here, histogram. Nice. So I'll hit histogram and I'll enter to state that it's there. Or just hit it. You don't have to enter it for this one. List. Well, our data was on this one, so therefore this one. However, I don't have a list 2. If you have a list 2, you're saying there's some type of frequency. So if I try to graph it right now, it would say dimension error. I don't have no list 2. So over here, I had to put frequency 1. Okay. And the options are here. So everything's good now. Now I could go ahead and say enter, and I go over here to graph 1. As I say, wait, what do you want to start? This starting point is your lower limit, your first class lower limit. That's what it really is. And the width here is short key saying class width. So we're going to be sure our first lower limit is 10, so it's matching good. Over here is 15, so it's matching. So if you need to change it, all you got to do is have it highlighted. And let's say over here, let's say it equals 2. I didn't want to. So I highlight it and I type in 10 and I press enter. That's what we do, change it. Same thing for class width, 15. I could highlight it, I write in 15, and I press enter. So to make sure that it has been changed. And now I could press draw, exit to draw, so or E fxCG50.exe, and there's my grid right there. So one thing I didn't hit on last time, but I'm hit on now, is it's the scaling. But right now we have the graph, so we're good with this. And what we're definitely seeing here is if I do trace, which is right here, but it's in yellow, so don't press this button right away. You have to do shift, because shift is on yellow, or in this case orange. So shift, trace. So now what we're seeing is I see this x value. This x value means the lower limit of the current class. That's what it means. Okay. And this f here means frequency that corresponds with it. So I know for the first class, it's going to be 6. If I press to the right, I have a second class which is going to start at 20, drawn to 25, and that's correct. It's 25 on the board. So I know its corresponding frequency should supposed to be 7. So the cool thing about this is notice how it's giving us the lower limit. So we could figure out the lower limit without having to constantly add by using the CASIO. It pretty much gives it to us right away without having to do all this extra work that other graph crackers might have to do. So it's a good, this is a good calculator to have, and it does reduce the amount of time spent. But anyways, if I go to again, lower limit 40 for the third interval, frequency 4. Well, third interval is definitely 40, so we're good. Push again, lower limit 55, that's correct for the fourth interval. And we know its corresponding frequency. And over here, lower limit 70, that's good. And over here, the corresponding frequency is 1. So the only thing that this guy here doesn't give us is the next lower limit. But if you press to the right and you're outside, it actually does. It's right here. It turns out it's 85. So we know the real limit of the last interval is 85, and then we could adjust it and get the upper limits like we did before. So this one here actually does give the lower limits without us having to calculate it, which is interesting. I like that. So let's go over here quickly and adjust the frequencies. Right here was supposed to be 6 for the frequency of the first class, 7 for the second class, 4 for the third, 2 for the fourth, and 1 for the fifth. Nice. So one thing you kind of notice over here on this graph, the scaling is pretty bad. Having a 5 scale like that is not that good. See, it's 5. So what is this number? I don't know this number. I knew I found it was going to be 7 over here, but the scaling is bad. If I need to graph it, I have to have good scales. I have to have even scales. So when they okay, I'm looking at 7, right? So over here, it turns out that's how many grids we have. 1, 2, 3, 4, 5, 6, 7. Okay, well 7 could have fit, but that's not always the case, okay? Don't think it's always the case. It could have been one less. Oh, 7's not there. Maybe you can put one more grid here. Maybe, if you have space, if it's possible, you can. But I'm going to the situation, maybe it's not. Maybe I don't have enough. Maybe it was 5. These guys were out. And I want to have this to choose from. How can I rescale it? How can I deal with that? Well, over here at the day, okay, well the maximum is 7. So I want to make sure I have a number that's either this 7 or greater than 7. And I want to have even scales from there. So we can look over here and we say, okay, scale. What do I want my scale to be? Well, I could do even. So I could make scale be 2, and I want to go get to the max. That is 8, because 8 is greater than 7. And this even scales 2, 4, 6, 8. That's not bad. And I can put this on the grid. So over here we have 0, 2, 4, 6, 8. Oh, this there, it fits. I could continue on, put 10, 12, 14 if I wanted to. But I know the maximum is going to be here anyways. So I have the scale 2, and I definitely have 8 here. So if I have 8, this 7 is going to definitely be graphable, which is the best part. One thing I got to mention here is, if you notice up top, the x-axis on the graph happens to be the values, the measures we have, the variable we found, the data we obtained. Okay, is always going to be the x for frequency distribution like this. So what we're saying over here, this y-axis right here was actually corresponding to the frequency, which was the x that we saw, the frequency. So this y-axis right here is actually frequency. So I'll put in frequency over here. So I'll just right here frequency. Now put in short. And we know this x-axis right here was the variable measure. So we're looking at driving time. Okay. And it's in minutes. So it's very good to have the units there because these people say, well, is that hours? Is that seconds? Is that days? Someone drove for 7 days straight. Is that even possible? So these are things you have to make sure if there's units, make sure you have the units there. People who your audience or you're trying to explain to has to know the units. So come over here. So now it comes up to the x-axis. Notice over here they went based off the real limits, which is great. Come over here. Either you're going to be doing real limits or you're going to do boundary points. But we know we already got the boundaries here, and we know what they correspond to. So we know that the boundary points for 10 and 25, if I did the dp, number right here, dp, what bp mean? Its current point bp was actually 9.5 to 24.5. And if you want to look at the boundary points for this guy here, BP, we definitely see it as being 69.5 to 84.5. We're seeing that. So either you could have it here as, depending on what your task is doing, just keep it consistent. The midpoint, midpoint for your book, if the book says boundary points, do boundary points. So come over here, I'm going to have my 9.5 because our book actually does boundary points. Come over here, we're going to have the next one over, which is going to be the 24.5, followed by the 39.5, followed by the 54.5, followed by the 69.5, followed by the 84.5. So we got that in there. So all we're going to do now is graph the histogram that corresponds with it. And these are rectangles that are connected, like you see over there. Well, let's see. The first one's supposed to be 6, right? So we know that from 9.5 to 24.5, we usually have a height of 6. So therefore, the 6 is on the grid line. That's good. So I'll make sure that it's consistent on the grid line and make the rectangle as good as possible. Next one was 7. Well, 7 is on the grid line, but I know it's halfway between 6 and 8. Nice. So I go halfway up and complete the rectangle for it. So we have 6 here, 7 here. Next, we have 4. Well, 4 is on the grid line, it's right here. So I could draw its rectangle appropriately. So we have 4 there, followed by 2. So 2 is on the grid line, that's good. So I'll make the rectangle that corresponds with it. So there's our 2 frequency. And last one is 1. Well, 1 happens to be halfway between 2 and 0. So I'm going halfway up. And there's my 1. I have now graphed my frequency histogram. And it definitely looks just like the graph we have over here. The only difference over here is I don't have the proper scaling. So my scaling is not looking like that. So so on the calculator, I could readjust the scaling to look like that, which is great. So all we gotta do here is how do we adjust the scaling? Well, we have something called view window. V window, which means view window. So the notice says it's yellow, so don't press the button right away. We have to press shift first, then view window. So that's what I'm gonna do. I'll first press shift, then notice over here it says trace, zoom, view window, shift, or sketch. So now I choose view window. Over here, I don't need to touch any of these guys. They're pretty much good where they are. But come over here to the Y. This is not bad, but if you want to change it to adjust it, you can always do that. But make sure it's in the negative because we want to be able to see the x-axis. If you don't put a negative, we can't see the x-axis, then we don't we want to see the bottom grid or the bottom scales. Over here, max for the y's. We were aiming for the 8, right? So we could pretty much keep it consistent. Even though ours was 14, we could keep ours at 8 still. Okay. Enter. Scale. Our scale we chose was 2. So just make sure for our scale we put 2. Now this, we can just do that 0. We don't have to change any of that. And I'll enter. So now everything is set up. Now I'm going to go back to my graph, and I'm going to graph 1. Not change anything. Now notice how we have our scales. And it's matching for what we have up there on the graph. We're the graph by hand. So you can literally put the scales on a calculator, or adjust it according to a calculator, so that when you graph it on by hand, it's not too difficult. Okay? But the graph requires clue now because I can actually capture this image of this, and I could use it as a reference when I go ahead and do that presentations. So it has its wonders, its perks. Okay, so that's that. The next thing here I want to talk about is polygon, and that we promised into this is polygons and how polygons is done and how it's graphed. So what we're going to do here is, where's my red, over here. So I want to put the polygon in red. I was going to do black, but I have blue down here. So I'm going to point out where the midpoints are at. So midpoints. What is a midpoint actually? A midpoint is pretty much mid-distance between the intervals. So this mid-distance should actually be either the real limits, that's the true length of the interval, or the boundaries. I know the book says use the upper limit, but those are not really the true intervals. Okay, keep that in mind. Those are not really the true length of the rectangles. So I would prefer using boundary points, or in this case, since we have several region boundary points here, I'm going to keep boundary points. And we'll see it when we actually do it. We're doing midpoints. So the mid between these guys here is here. And we're going to find out what that mid distance is pretty soon. I guess it's going to have to be the color in red. But we're going to do a corresponding point right here. Bam. Now, midpoint between 24.5 and 39.5 is somewhere over here. We'll find out what this guy is soon. What corresponds, and there it is right here. I'm going to go back because the red is somehow mixed in with the yellow and green, and it's changing on me. So I'm sorry about that. But I'm just going to be here. I'm going to make this line black, this point black, this line black, this point black, which means midpoint. Okay? So over here, mid distance between the two, that will be the midpoint we're going to be finding shortly, and we put the point that corresponds to it right there at the top of the rectangle. And I repeat the process over and over again. Right here, this appears to be about midway, and there, about midway, so it should be here. One thing we're going to catch on, and it's the key thing we have to understand, is that the polygon actually supposed to start at 0 and end at 0. It is not starting at frequency 0 here, and it's not ending at frequency 0 here. So what we're supposed to be doing to keep it and make sure it does what it needs to do, we're going to be going one midpoint beyond this upper limit. One midpoint beyond this last interval. So it's pretty much like over here, keeping the same distance, class width you could say. And over here, we're going to have our 0 on that region. And I'm going to go one midpoint to less than the first interval, which if I do halfway, it's about here somewhere, if I keep equal class width. And in this region, I will put my 0. That's what's happening there. So by hand, we could figure out the graph without, we could see what the graph looks like without having to draw a new graph. But usually we do draw separate graphs. So the practice is showing that, hey, it's the same graph, just different information is being done. So now I'm just going to connect the points together, which means I'm making a line graph. So Notice how it looks kind of like a mountain, more like a skewed, pushed over mountain. But what we're seeing here is the polygon and the histogram both show the same distribution. So I'll put the note here. The green is our histogram. And the black graph we have here is a polygon. Where histogram deals with either the blue limits or the boundary points, and the polygon deals with the midpoints that are corresponding with the boundary points. That's what we're getting here. Okay. So now, so what are these values? Because if I open a calculator, I need to know the values. I need to know exactly what those values are. So how would I figure that out? So what we're going to do over here real quick, I'm going to ask on the midpoint. So over here, midpoint. Once again, your book says get the upper and lower limit of each of the interval you're looking at. But I'm going to show you a technique that's going to help us get it the same way we did the lower limits, how we found all the real limits using the plus 15. So all we can do is we can use any one of those guys. I'm going to either be adding or subtracting 15 when we get to them. So all we do is we find one and we find all the others naturally, instead of doing them all individually. But come over here, let's go ahead and do it first. So what we're seeing here is we're going to do what the book says, lower limit plus upper limit of the interval we're focusing on. And then we're going to divide by 2. So let's just go ahead and use the first one for our sake. So we're really looking over here, we're seeing 10 plus 24, all that divided by 2. If you do this by hand, do the word use our operations, we're currently looking at 34 over 2, which ends up becoming 17. But that's what we were saying. Well, if you know how I was graphing it, I said, well, I went halfway between boundary point and boundary point, and I said that's what the midpoint is supposed to be. So I'm going to keep to the same thing. I'm going to look at boundary point to boundary point. I'm going to say, hey, we're getting the same answer. So what I'm putting over here this time is I'm going to actually, for the second method, so you can see this one here is method 1. Okay. Method number 2 is the boundary point. So what we're doing here is we're seeing the sum of the boundary points. So I'm going to write here sum of the intervals. In our case, class, I usually say interval because that's what makes the values. The sum of the class, aka interval, boundary points, B, P. And we divide it by 2. So if we look at the same boundary points for the same class, we know that the boundary point is supposed to be 9.5 plus 24.5. And when we do this one, we're going to actually end with the same value, which is 30, well, I'm sorry, over 2, which is going to be 34 over 2 again, and that's 17. So I keep to this boundary because that's what I see on the graph, and I just use it. But anyways, okay, so how would you calculate this? Because once again, all of our operations is required here, and sometimes you might get decimals, so you're like, oh, okay, how much was round? What am I supposed to do? Give me some help here, some support. But once again, we should already have that already underneath our sleeves for the most part. But anyways, come over here. So I'm going to do a calculation, so I have to get out of stats. So I'm going to hit menu, and I'm going to be selecting run matrix, which means calculate. Similar to that, and note we have separated here. If you want to clear it, and these things, all you have to really do is go ahead and we're going to jump, see delete right here. You just press delete and say line or all. Well, I want to clear all, so I just press clear all, and yes, I want to get rid of all of it. Everything goes away. So that's all we need for that. So let's go ahead and put this in, and I'm going to do fractions setup. So let's go ahead. I'm I'll do the boundary one, so you see, hey, it actually it's gonna be 7 either or. So how do you do fraction? What fraction button is right here? That's the fraction button, so you can hit that, and I actually have 7 on top, that's okay, easy to delete it. And I'm gonna be putting 9.5 plus the 24.5 divided by 2. I wrote the same expression that I have on paper. And if you need to go back up, you can change this just up and down it. You could navigate through it just by pressing the directional arrows on this keypad. And if it does not exit it, and if you need to outside, there you go, make sure you have a big line outside. And what I'm going to do here is I'm press enter. And look at it, I get 17. I have confidence in my math. So, okay, I found one. Do I really want to keep doing this fraction thing for everything? That might take some time. So, is there an ultimatum? And the answer to that question is yes, there's an ultimatum. We already know that each of these intervals, interesting thing, lower limits, aka real limits, they are all the class width away. So 15 away, 15 away, 15 away for the real limits, from lower limit to lower limit. But look at the boundary points, same things are happening here. This here is 15 away. I can't speak right now. It's pretty much 15 away if you subtract, 15 away if you subtract. So if they're all following the same pattern, shouldn't the maker be doing the same thing? 15 away, 15 away, 15 away, 15 away. They keep consistent? And the answer is yes. We have to keep it consistent. So, therefore, all I gotta do here is say, well, let me just add 15 to it. Oh, that's 12. 15 to it. And there it is. 32 is the next one down. And I could repeat the same process again. Enter it again. 47. Enter it again. 62. Enter it again. 77. So I know what all the corresponding intervals are now. So I can pretty much come over here and write them in. So once again, the first one over here was 17, followed by 32, followed by 47, 67, 62, and 77. And once again, I'll show you what we just did. And all we did here was simply add 15 to get to the next one down. Plus 15 again to get to the next one down. That's all we did. That's all we did. So, therefore, we have the corresponding midpoints that go to the frequency that we have. Okay? But once again, that's not the only thing we want to do here. And also, let's remind you to put this into the data set, which we'll be doing another list. But let's just go ahead and see what's happening here. Okay, for the polygon. So what we're doing here is we have to go one beyond. Where's my black? Screw it. And I have to go one beyond to get over here to the 84, to get past the 84.5 to the next maximum point. So that means to get one more, all I just gotta do is add 15 here. And when I add 15, it actually is going to become 92. I don't need the black. Okay. It's actually become 92. So we know 92 is going to go here, and it's supposed to correspond to 0. And like we said before, we also need to go one midpoint before the first interval. So in order to get to that midpoint, I simply do the opposite operation, which is minus. And when we do that, it's going to end up becoming 2. And once again, you can do it in a calculator to prove me right. And we should know the corresponding frequency for 2 is supposed to be 0. Okay. So we get that out of the way. And once again, every single time I do this, I forget to show you how we could actually grab the frequency distribution table. We could have the histogram use the frequency distribution table. So I'm gonna do that right here, right now. Before I do the polygon, I'm gonna graph this frequency distribution table to show that, hey, using this table that we found, I could graph it and I'll get the same result as I did using the data. Okay? Using the data itself. And then I'll go ahead and get the rest of it. So before I do that, I'm gonna pretty much just highlight what it is I'm gonna be putting into this number 2. Or into this 3, 4. Anyways, first thing first, I gotta have this labeled in the list. So I already have this 1 bit of data. So this right here will be this 2. So this is going to be this 2. That's what we'll do. Just for the frequency portion over here, that I'm not doing everything else yet, I can get the frequency portion at this time, and of course correlate that with the intervals. So I'll let this be this 3 for right now. So let's go ahead and do that first, and then we'll back our polygon. Okay, so this 2, lower limits. This 3, the frequency that corresponds to an interval. Let's get that in here. So once again, how do I get to the stats? Well, first hit menu, select stats, and in this 2, I want to put the lower limits. So we're putting 10, 25, 40, 55, and 70. Those are the lower limits corresponding to each interval. Now I'm going to write in the corresponding frequencies for each interval, which is going to be 6, 7, 4, 2, and 1. So now what we have here is that I have a list that has all the data values. We have lists that consist of the frequency distribution information, where the first one was our interval, our the lower limits of our intervals, and the second one was the frequency that corresponded with it. So if you have a frequency distribution table, you could actually graph it using your calculator.